Hi everyone. Welcome to Unit 5 Polynomial Functions. Today we're going to talk a little bit about just an introduction to polynomials. I will let you guys know my stylus, currently the battery is not working, so I'm going to go through some already pre-filled out older notes to make sure that you're caught up. If at any time during this video you need to pause, please feel free to pause the video, and then you can always watch it. Catch up on your notes and then unpause or even try some of the problems first. So today we're going to classify polynomials, describe the shape. We may sketch a graph depending on how long the video goes, and then create an equation doing zeros. So a little bit about the vocabulary of polynomials. Polynomial is one or more monomial. It has positive integers and exponents. A lot of this you've probably seen before. It's just kind of a nice little refresher. One term is a monomial, two terms is a binomial, and then three terms is a trinomial. If you have more than three terms, we usually just say like fourth term polynomial or polynomial of four terms. Some things that are not polynomials. Any equation that has a negative exponent, any equation that has a radical sign. The degree of a polynomial is the greatest exponent of one of the terms. So for example, hopefully they should all be in descending order, but sometimes it's a little bit more difficult whenever you have a factored form. So if you take a look at the two examples here, x squared plus 2x plus 3, the highest degree is 2, so our highest exponent is 2, so our highest degree is 2. Whereas factored form is a little different. With factored form, we have to make sure that we add all of our exponents together in order to get our lead degree. Because if we FOILed it out, big picture, if we FOILed everything out, we would have a fifth degree polynomial. Next, we're going to take a look at the shape of the graph. So the reason that we have degree is it identifies the shape of the graph. The degree, remember, is the maximum number of x-intercepts possible, or it helps us determine the maximum number of x-intercepts possible. So if the degree is even, the ending of the graph will point in the same direction. So for example, if back to x squared, if it's x squared, x to the fourth or x to the sixth, generally speaking, it'll go up, up. If the highest degree and then there's a negative out front, like negative x squared, negative x to the fourth, and so forth, then our graph will go down, down. If the degree is odd, the end of the graph points go in the opposite direction. So x to the third, x to the fifth, x to the seventh, and so forth, even x to the first, will start down and then go up. However, if there is a negative out front of our highest degree, our arrows will be switched around, or the way that our graph goes will be switched around. For instance, negative x to the third power, negative x to the fifth, and so forth. Next up is how we relate something called multiplicity to the graph. Multiplicity is the number of times that an x-intercept factor appears in the equation. So odd multiplicity means the graph goes through the x-axis at that zero. Even multiplicity means that the graph touches or bounces off the x-axis at that zero. So essentially, you have a polynomial. After you get the polynomial into factored form, there is going to be an exponent on each of those factors. If the exponent is odd, it will cross through your x-axis. If the exponent on one of those factors is even, it will touch or bounce off of your graph. So let's look at a couple examples here of just finding multiplicity, finding degrees, zeros, and just describing everything in order to graph. If you take a look at this first example, we're already in factored form. in order to find out what our highest degree is going to be, in order to determine our end behavior, we're going to have to add our exponents since it already is in factor form. So 2 plus 6 plus 3 gives us a degree of 11. That degree of 11 is odd, meaning that both of our ends are going to go in opposite directions. Because out front of our x squared, it is positive. That means that our end behavior will start down and then go up. Okay, so that's the first thing. That's why we determine that degree, is to determine the end behavior. Next, if you look at zeros, so we have to find the zeros of each. So if you look at our factored form, we have 3 zeros. X squared is equal to 0, x minus 4 is equal to 0, and x plus 7 is equal to 0. We solve like we've done in the past to find out what each of those zeros are, or where our graph is going to touch or cross the x-axis. Next from there, we need to find out what the multiplicity is going to be. Remember, if it's an even multiplicity, it will touch. If it's an odd multiplicity, it will cross through. So, because x squared is squared, it's even, which means that it will touch x, where x minus 4 becomes 4. It is a degree of 6, so it will also touch. And then because x plus 7 becomes negative 7, it has an odd exponent of 3, we will cross through our graph. So the first thing that we do whenever we graph is we start by plotting our points of where our zeros are going to be. So the first thing that I do, I know this is all kind of already plotted out for you, but I want to show you the first thing that I do personally is I plot all of my x-intercepts. So there's all 3 of my x-intercepts at negative 7, 0, and 4. Next, I just write my arrows for my end behavior based on my furthest zeros. So for example, I will go to this 0 of negative 7, and from there, I will just draw an arrow straight down. I'll also go over to my 0 of 4, and I will just draw an arrow straight up, signifying that I know that the end behavior is down and up. Lastly, I'll fill in the little details of whether I touch and cross. So I'll start at negative 7, and I notice that I cross through because that multiplicity is odd. So I'll cross through. It does not matter how high you go. We're not worried about that right now. We just want to see whether you cross or touch. And then I'll go to 0. At 0, I touch. So I'm going to bounce off of my x-intercept. I'm going to go back up again. I'm going to come right down. Again, it does not matter how far up or down you go right now. I'm just mainly looking for, crossing and touching. And then once I get to that last point, which is my 0, 4, it is even as well with the 6. So I bounce again, and then that shows me how my end behavior is going to play out. So you can kind of see the big picture. Okay, so what happens if you have something that is not in factor form, that is in fact in standard form? You will have to factor everything out of it. So if you look at example number 2, we've got negative 4x cubed plus 4x squared plus 15x. I'm going to take a negative x out. I think it's easiest to take that negative out first. That way you can factor. So 4x squared minus 4x minus 15. From there, that factors into 2x plus 3 times 2x minus 5. So now I'm looking at this negative x, parenthesis 2x plus 3, 2x minus 5. I know that my highest degree, 1, 2, 3, I have 3 of them. They're all a degree of 1. And then that kind of fits because my highest degree here was a 3. Don't know why this cut off in my notes. Let's see if I can draw this at least with my finger for you. 3 there. So my lead degree is 3. Now this one will start down or up and then down because there is a negative out front. And then because I factored, I want to look at what my zeros are going to end up at. So negative x was 0. 2x plus 3 becomes negative 3 over 2. 2x minus 5 becomes 5 halves. And then I want to go ahead and I want to plot those after I look at my multiplicity. My multiplicity on each one of them is 1. That comes from this being 1, 1, and 1, which means they're each going to cross. So whenever you look at your graph, again, first thing that I would do personally is I would just draw a little dot as to where all my x-intercepts are. I go on my furthest left, and it says that I'm going up, so I draw my arrow up. I go on my furthest right 0, it says I'm going down, so I'm going to draw my arrow down. And then on each one of these, because my multiplicity is odd, I'm going to cross through. Again, it does not matter how far you go with that loop. We're just going to cross through. We're not too worried about that right now. Big picture. Again, here's another example. Before I show you what's going on, I know I've got a couple things circled, but why don't you go ahead and try that problem. Pause the video. See if you can find your degree, so therefore your end behavior, which I'm sure that you guys can see that now, actually, as I'm looking at this video, and then determine what your zeros are and your multiplicity. Hopefully you are done and pausing the video. Take a look at your zeros, multiplicity, and then how your graph is going to end up looking. That should be a negative 2 there. All right, so last thing that we're going to talk about here is creating zeros. So whenever you do this, you actually want to work backwards. If you take a look at what I'm going to show you here. So we've got zeros at 0, 1, 4, and negative 3. We're going to work backwards. So we're going to set each of those individual numbers equal to 0. And then we're going to move everything over to the opposite side. So you have all the numbers with the x combined. These are what we call your factors. So take a look and see how those factors were created. Now, once you have those factors, you're going to write them all out, and then you'll use polynomial multiplication. So distribution, FOIL method, whatever you need to in order to simplify and get your solution. How this becomes a little bit trickier is whenever you have things like multiplicity of 2 or fractions. You cannot have fractions within your writing. For instance, if you look at example 5, okay, 0's at 1/2 and negative 2/5 with a multiplicity of 2. I write x is equal to 1/2. I write x is equal to negative 2/5. And then I can't just say x minus 1/2 or x plus 2/5. I actually have to multiply. So like with the x is equal to 1/2, you multiply by 2 and then subtract 1. With x is equal to negative 2/5, you multiply by 5, you add 2, and you get your two factors, your two binomials. You're going to put those together. When it says multiplicity of 2 or multiplicity of 3 or multiplicity of, that's just to what degree your binomial is. So in this case, the 5x plus 2, it's a multiplicity of 2, so it'll be 5x plus 2 squared, which then you'll have to solve out. Again, you may need to pause the video just a little bit on these. Last but not least, creating zeros with radicals. Same exact way, with 1 plus square root of 3, you're going to subtract everything over. 1 minus the square root of 3, you'd subtract everything over. And then you have to multiply out. Now, this is a little bit more difficult just because it's with the radicals, but I think with the honors level, you guys have done this before. You'll notice, too, that a lot of the square roots will usually cancel themselves out. And that's all I have for you today.